All right, this is chapter 3, Powers and Exponents, and your second lesson, using powers to describe numbers. We're going to continue to work on understanding what a power is, what a base is, and what an exponent is. And we're going to continue working on repeated multiplication and representing values as a single power. But we're also going to add in some negative integers and brackets. And so by the end of today, you should know why brackets are used with powers and how using brackets can impact the value of a power. So, first example, it says 3 to the power of 6 is the same as 3 times 3 times 3 times 3 times 3 times 3, or 729. And we had this example in your lesson 1 notes as well. And I want you to think of, are there any other ways using powers that we could show this value? So 3 to the power of 6, we can just go straight to 3 to the power of 6. But we could also think of it as 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2. So 3 squared times 3 squared times 3 squared. Or we could think of it as 3 to the power of 3 times 3 to the power of 3. Okay. Or we could think of it as 3 to the power of 4 times 3 to the power of 2. So there's a whole bunch of different combinations that we could be thinking of. So I want you to start thinking of this when you look at powers, of how else can they be broken down. This will be important as we start looking forward in further lessons, not so much for the rest of today's, but definitely going forward. So I want you to have this idea in your head already as we're looking forward. So we're going to write these values as repeated multiplication, and I want you to notice when brackets are used and when brackets aren't used. And so in previous lessons and previous ideas, we've always used a bracket around an integer to help keep that sign with the value. So like -4, we put the sign around it to show that it's a negative value, that the negative sign belongs with the value 4. That's really important when we start looking at exponents. So remember, we say for exponents that we have a power, and so we've got a base, and then we've got the exponent. And the base is what gets repeated, and the exponent tells us how many times it's repeated. So the whole base gets multiplied, and in this example, because we have the brackets and then the exponent outside the brackets, everything inside the brackets is our base. So the -4 is the base that gets multiplied 3 times. Okay, so we go -4 times -4, so that's going to give us a positive 16 times -4. Positive times a negative, we know we get a negative solution, and a -64. Looking at our second example, again we have brackets. Again we have a negative base inside of those brackets with the exponent outside the brackets. So that tells us that everything inside the brackets is our base, and they're going to be multiplied 4 times. So -2 times -2 times -2 times -2. So then in this example, -2 times -2 gives us positive 4. And I'm going to jump down and do these last two and go -2 times -2 is positive 4. And positive times a positive gives us positive 16. So in that first instance, we had a negative base that ended up with a negative solution, or a negative value. And then in B, we had a negative base inside exponents. However, we ended up with a negative base inside our brackets and ended up with a positive solution. Now when we look at C, B and C are very similar, except now there are no brackets on our base. And so that tells us that just the 2 is the base that gets repeated 4 times. So we have a negative 2 times 2 times 2 times 2. So it's almost like there's a negative 1 being multiplied out front. We'll explain a bit more about this after. So again, we go 2 times 2, which is 4, 2 times 2, which is 4, and we have the negative out front. So negative 4 times 4, so negative 16. So again, similar base, same exponent. However, because there were no brackets, the value is negative. Looking at D, we have a negative outside the brackets, and we have a negative 5 base. So negative 5 is our base that gets repeated. I'm going to put the negative out front, and then negative 5 times negative 5 times negative 5. I'm going to leave that negative out front for a second. We know that 5 cubed, or 5 to the power of 3, is 125. It's on our perfect cube table. And negative times a negative gives us a positive, and positive times a negative gives us a negative. So this is a negative 125. But we still have this negative up front. So negative times negative 125, this actually makes it a positive 125. You might be noticing a pattern, or you might be noticing some frustration at this point. We'll talk more about this. So I would like you to decide for yourself if 3 squared is equal to negative 3 in brackets squared. Again, you're going to say yes, it does, and provide some reasoning behind that, or you're going to say no, it doesn't, and provide some reasoning behind that, and we are going to discuss this in class tomorrow. All right, we're going to write this as repeated multiplication, and we're going to see what kind of patterns we notice. So again, the negative 5 is in brackets, so that is our full base. So it's going to be negative 5 times itself 4 times. And so negative times a negative gives us a positive. Negative times negative gives us a positive. So we will have a positive solution. And if you type either of these equations, or pardon me, expressions into your calculator, either bracket negative 5 bracket up arrow 4, or negative 5 times negative 5 times negative 5 times negative 5, you should get positive 625. When we look at B, again, the negative exponent is in brackets, and so the negative base will be repeated 3 times. And negative times a negative is a positive. Positive times a negative gives us a negative. And if you type either of these into your calculator, either expression, you should get a value of negative 729. So I want to point out that we had an even exponent in A, and we had an odd number exponent in B. If we go back to your last page, we had, oops, too far. We had an odd exponent in A and a negative answer. We had an even exponent in B and a positive answer. So hopefully you have seen our pattern, that when the base of a power is positive, okay, so when the base of a power is positive, so the base is 3, no matter what, we will always result in a positive number. or a positive solution. Okay? So 3 squared or 3 to the 3, doesn't matter, we're getting a positive answer. However, when we have a negative base and an odd exponent, the result will always be a negative value. Now, this is excluding something like D on the last page, or, D on the last page, because we have that other negative out front. It kind of messes with this pattern a little bit. And then, so if we have a negative base and an even exponent, we are going to have a positive solution. So every time you have even numbers of negatives being multiplied, the two negatives multiply to make a positive and cancel each other out. Okay, last 3 examples. We're just going to write these out as repeated multiplication and then figure out what our solution is. So we've got this negative out front, and then we've got the base of -4 times -4 times -4. So we have 1, 2, 3, 4 negative signs, an even number of negative signs being multiplied, we get a positive 64. 4 cubed, 64 on our perfect cube table. For B, we have a positive base because there are no brackets, and so the negative goes up front, and then 8 times 8 times 8 times 8 times 8. So there's only one negative there, so we're going to have a negative solution because that's an odd number. And 8 to the power 5 is 32,768. When we look at C, the base is negative and the exponent is even, so we should have a positive solution. -7, -7, -7, -7, -7, -7, -7. 1, 2, 3, 4, 5, 6 times. And these two negatives make a positive, make a positive, make a positive. So we end up with positive 117,649. Okay, guys, that's it for lesson 2.